All right, 13.3, a circular approach homework. So on a couple of these, what you can do is you're going to see me take away things like 2 pi or stuff like this. Like 15 pi over 4 is not on the circle. But if I take away 2 pi, I should get 7 pi over 4. And I know you're like, how does he do that? What kind of magic is this? Well, fractions, kids. 15 over 4, take away 2, back is a fraction. 7 pi over 4. Now, 7 pi over 4, if you think about your circle, is right here. And the ordered pair there is root 2 over 2, negative root 2 over 2. Now, on the unit circle, the sine of some angle is simply the y value. And the y value here is negative root 2 over 2. So the sine of 15 pi over 4 is negative root 2 over 2. Now, why did I take away 2 pi? Because of coterminal angles. All right, 10 pi over 3, not on the unit circle. So I'm going to think about coterminality. I'm going to take away twice pi. And 2 pi is going to be 6 pi over 3. 10 minus 6 is 4. 4 pi over 3 is the angle I'm interested in. So 4 pi over 3 is going to be about right here. That's 240 degrees. And the ordered pair there is negative root 3 over 2 and then positive 1/2. Sorry, also negative 1/2. Now, cosecant on the unit circle is going to be the radius divided by y. And this is a unit circle, the radius is 1. So it's 1 divided by negative 1/2. To divide by a fraction, we multiply by the reciprocal. So we take 1 and we multiply it by negative 2 over 1, and we get negative 2. All right, good with that. Moving on, let's look at 6. That is a negative angle. So let's add 2 pi. If we plus 2 pi to it, that would still be negative 5 pi over 3. If we plus 2 pi again to it, that would be pi over 3, which is one of those angles in quadrant 1. That's 60 degrees. That's right here. The ordered pair being 1/2 and root 3 over 2. Now, the secant ratio on the unit circle is going to be the radius divided by x. Radius is 1, x is 1/2. 1 divided by 1/2 is 2. Moving forward our lives here. Theta's terminal side passes through the given points. Find the requested trig ratios using the circular approach. So according to the circular approach, r squared is x squared plus y squared. This is actually a special pattern. It's a 5, 12, 13. But r squared is a negative 5 squared plus a 12 squared. That's 25. That's 144. R squared is 169. So the radius is 13. Now find sine. Now, according to the circular approach, the sine ratio is y over r. So it's going to be negative 12 over the radius of 13. The secant ratio is the ratio is r over x, radius being 13, x value being 5. Easy peasy lemon squeezing. 11, just because she has some radicals in there. First off, we'll have to figure out the radius. R squared is a root of 3 squared plus negative 5 root 2 squared. If you square a root of 3, you get 3. If you square a negative 5, you get 25 times 2. You get 50.
At this time, we have a surprise for all of the students.
Oh, they're doing this early.
The gym doors. So at this time, all seniors, please go and get a snow cone. Only seniors at this time.
Anywho, root 53 is not something that simplifies. I don't feel that it simplifies. So there's my radius. All right, cosine of an angle when you're using the circular approach is x over r. So this would be root 3 over root 53, which is just an ugly number. We're going to multiply top and bottom by root 53. 3 times 53 is 159, so root 159. And root 53 times root 53 is 53. And And will that simplify? 150 is divisible by 3 53 times, but I can't take the square root of either one of those two, so this thing is done. Moving forward, alpha's terminal side passes the given points. Use the triangular approach and reference angles to evaluate the requested trig ratios. I don't know why it talks about reference angles. That doesn't make much sense. That needs to be straight through. But you don't need the reference angles. All right, so alpha's terminal side passes through an angle. This one goes back 3 and up a root of 6. Now alpha, the Jesus fish, is actually this angle. We use something called alpha prime, but it's cool. I think that's why it says reference angles, because you're using alpha prime as opposed to alpha. So anywho, the secant of alpha prime would be So hypotenuse, which isn't given, over the adjacent side, which is -3. And we're going to have to figure out the hypotenuse. We're going to have to do -3 squared plus root 6 squared equals c squared. That's going to give me 9 plus 6, which is 15, equals c squared. C is root 15. Now, negativity belongs to the numerator, so negative root 15 over 3. And then you got to have the tangent of alpha. Tangent being opposite over adjacent, so negative root 6 over 3. Easy peasy lemon squeezy. What do we got here next? We got 15 is the next one I'm going to do. Angle F's terminal side intersects a circle with a radius 4 at -3, negative root 7. Evaluate the sine, cosine, and tangent of F. After evaluating these ratios, use the arc sine, arc cosine, and arc tangent to determine angle F's true measure. Kind of a big deal because things lie because of where this thing is. Now, this thing goes back 3 and then falls 7. Put F prime there as a reference. Back 3, down root 7. Do a little Pythagorean theorem. We'll have 9 plus 7, right? 16 is c squared, c is 4. Hypotenuse is 4. Seems legit. All right, so the sine of F would be opposite over hypotenuse, negative root 7 over 4. The cosine of F would be adjacent over hypotenuse, negative 3 over 4. And then the tangent of F would be, bless me, negative root 7 over 4. Got tired there. All right, so now I'm saying use the arcs, the inverse ones. So the measure of angle F would be the arc sine of negative root 7 over 4. The measure of angle F could also be the arc cosine of negative root 7 over 4. And then the tangent, the measure of angle F is the arc tangent of negative root 7 over 4. And you know what's funny? None of these answers are going to be correct. Absolutely none of them are going to be correct. At best, a TI-84 gives you a reference angle, unless the angle lies in quadrant 1. All right, so, when we use reference angles, we're actually talking about the reference angle. We're not talking about the full angle. So I may not be clarifying on that. Remember, this is the angle. That's the angle. That should be something more than 180 degrees, yay? So anyways, let's see what some of these generate. Funny thing about trigonometry, when you're dealing with a real world problem, you can trust that TI-84, but when you're talking about stuff like this, you can't trust it. That one says the measure of the angle is negative 40.41 degrees. Now a negative angle would look something like that, wouldn't it? This one is going to tell me something more than 90. I would say it's probably going to tell me 130.41 degrees. By the way, make sure your TI-84 is in degree mode. So I'm thinking it's going to tell me 130.41 degrees. What do I know? Ah, it did. Now that would look something like this. And finally, we have arctangent, and it's going to tell me the same thing that the first one did. I've done these a few times, kids. I know how these things work. Actually, it told me something entirely differently, didn't it? Well, now I'm just confused. Oh, because it's not right. It's not over 4. It's over 3. That's why. It was supposed to be the same as A. And it was over a -3. And it's 41.41 degrees, which would be an angle in quadrant 1. Now, what you actually figured out here was that this reference angle is about 40.41 degrees. Even this guy up here it didn't help you at all, did it? But this guy was just bloop for this. The 84s are funny, kids. They return reference angles at best. But you have to think about where the angle actually is to figure out enough information to actually get the angle. That's the fun part about tomorrow's lesson. Or in this case, probably today's lesson. Let's see, number 17. What is this guy? This is the Greek letter omega. Angle omega's terminal side lies on -4,7. Evaluate the sine, cosine, and tangent ratios. All you got to do is figure out your radius. R squared is -4 squared plus 7 squared. R squared is 16 plus 49. 16 and 49 makes what? 67. R squared is 67, so R is root 67. If I want the sine ratio, the sine of omega would be the y value divided by the radius. So it'd be 7 over root 67. We multiply numerator and denominator by root 67, and we get 7 root 67 over 67. If I want the cosine of omega, then I take x and divide it by r. So it's going to be -4 over root 67, which cleans up to be -4 root 67, sitting pretty over 67. And finally, if I want the tangent of omega, again, I'm using the circular approach, I'm going to take y and divide it by x. And I'm just going to get -7/4. Easy peasy lemon squeezy. The last one I guess I'll do is going to be number 19. From a hot air balloon, an angle between a radio antenna straight down below and the base of the library downtown is 57 degrees. So there's a hot air balloon, and beneath you is an antenna, and somewhere there is a library, and it says the angle between the antenna and the library is 57 degrees. It actually says it was in between, so 57 goes there. If the distance between the radio antenna and the library is 1.3 miles, how many miles high is the balloon? So I guess I should have said this is what it actually looks like, and that's 57. So we have this 1.3, and we need to know this unknown height. The height of the balloon is adjacent to 57, and this is opposite. So it turns out that the tangent of 57, because we have opposite and adjacent, is 1.3 sitting pretty over x. Takes 2 steps to do this. First one is we x both sides, because the opposite of division is multiplication, and then we divide both sides by the tangent of 57 degrees. And we get choice E. And that's it. That's your 13.3 homework. I'm not sure which day you'll be doing this because the schedule is kind of a mess for the next couple of days.